So now let's get into immunology. Edward Jenner is considered the father of immunology, and his major work was done on smallpox. So he was a scientist, he was a physician, and he was studying people that had smallpox. And he noticed that um, on the farms, milkmaids who worked with cows a lot, obviously, didn't get smallpox. But what they did get was a different disease that looked similar. It was called cowpox, but it was much more mild. And he had this idea that if you had cowpox, you couldn't get smallpox. So he had a young boy who was his apprentice, and he took his apprentice, this 8-year-old boy, and he infected him with cowpox. The boy got sick, and he got better after a week or so. And so then he decided to test his theory, test his hypothesis, that if you've had cowpox, you would be immune to smallpox. And he infected the boy then with smallpox. And the boy survived. So his work led to the work of individuals producing vaccinations. What he used was variolation to protect this young boy, his apprentice. And initially, people thought he was crazy, and they made a lot of fun of him. They were joking. They were like, wow, this guy's crazy. He thinks that getting sick with cowpox will protect us from this other disease. But eventually, they decided to listen because they got really scared of the smallpox, and they realized that the people that were listening to him weren't getting sick. So he is considered the father of immunology. So this is what cowpox looks like. It's a mild disease. It lasts a couple of weeks, and then you get better. This is smallpox. Smallpox is a very serious disease, often leading to death. And if it doesn't lead to death of the individual, then it does lead to disfigurement of the individual. So that was in, that was in the 1700s. So the end of the 1700s, around 1798. And Pasteur, so he is the one who debunked spontaneous generation. He's also famous for producing one of the first actual vaccinations. And so basically what he did was a mistake or an accident. He was working with chickens, and he was working with the bacteria called cholera, which causes severe diarrhea. And so he was infecting chickens with the cholera bacteria, and he left for an extended period, probably a week or two. Both him and his partner left, and so they left their bacteria in the incubator, and when they came back, they picked up on their research, and they infected multiple chickens with the cholera bacteria, but none of the chickens got sick, and so none of them died. And so they were like, well, the strain that we're using is probably too old, no big deal. They made some new cultures, and with the fresh cultures, they infected those same chickens, and the chickens still didn't get sick. And they were like, what the heck? So then they got some new chickens, and they infected the new chickens with the fresh cultures, and those chickens got sick and died. And this led to them realizing that the cultures that had been sitting for a long period of time had likely lost their virulence. And though they, or not and, I'd say, but though they lost their virulence, the immune system of the chickens still responded producing antibodies and memory cells. And so when the new pathogen got into their system, the immune system responded very rapidly and attacked, killing off the pathogens. And this is what led to the first vaccination. They called the attenuated cultures a vaccine in honor of Edward Jenner, who actually had figured all of this out. He didn't really know the mechanism behind it, but he did figure out how to protect individuals from a disease using a disease. And this leads us to the golden age of microbiology. So the golden age of microbiology is between 1875 and 1918. A lot happened. So we debunked the theory of spontaneous generation. We found a lot of those pathogens. We identified them, and we now know, okay, they cause these diseases. Viruses started being found, so now we know there's viruses out there that are non-living. They also cause disease. Because we now know that microbes cause disease, we started coming up with ways to protect ourselves: vaccines, antibiotics, other chemicals. Oops, sorry. Some of the diseases that were super dangerous, like smallpox, very devastating killer, was eliminated. We do have smallpox in a couple places on Earth, but they're in storage. I don't know why we keep those, but we're weird people, so whatever. Plague, which wiped out almost 1/3 of the European population, is now under such excellent control that less than 100 people die worldwide each year, mainly because the pathogen has been identified as Yersinia pestis, which lives in rodents. And the fleas that bite the rodents take the Yersinia pestis and pass it on to us. And so we can actually control the pest population, and that decreases the the bacteria in our areas. And then we also use antibiotics to protect ourselves. But we still have a lot of problems. Viruses are still very, very common, especially in developing countries. Again, diarrheal infections are common in developing countries. And even in the developed worlds, we are starting to see a lot of infections becoming more common again. Part of this is because of the change in our environment. So we're taking a lot of the land away from animals. And when you come in contact with animals that you normally don't come in contact with, the diseases that the animals harbor are going to become common to you. And they're not diseases that humans normally harbor, so they can cause a lot of problems. The environment is warming up. Because of that, insects are becoming more common and they're lasting a lot longer. Insects are some of the worst for vectoring diseases. So they might not cause diseases, but they transmit diseases from one organism to another, especially those really deadly viral diseases like and I can't think, Ebola, that's the one I wanted to think of. Ebola can be transmitted. Malaria, that's not viral though, but it is a disease. I can't think of the other one that I want to say, so I'm just not going to say it. And then some viruses have become more common in humans because they have evolved to be able to infect humans. So this table just shows where, in which countries and regions, that certain diseases are becoming more common in, and the dates when they became more common. Reemerging diseases. So certain diseases are coming back, partly because some people are not vaccinating. We're getting this whole movement of anti-vaccination. I think a lot of people are realizing that vaccination is uber important. So I think this anti-vax movement is actually starting to decline, which is great, excellent, because it's the stupidest thing ever. But when you have vaccination, it's really beneficial. If everybody's vaccinated, then you're basically protecting the entire um, group. It's like herd immunity. So everybody around is protected, even if they didn't get vaccinated, because they couldn't. When you get people that don't get vaccinated, they become more prone to these diseases. And if you're prone to a specific disease and you get that disease, then even people that have been vaccinated, if it's been a long time, if that disease has not been in the environment for years and years and years, those people could actually become prone to that same disease as well. Vaccination typically lasts between a year and 10 years. And then you usually want to get revaccinated unless the pathogen is common in the environment. Pathogens also become resistant to medications. So the best example is staph, I think, Staphylococcus aureus. Staph infections that used to kill people are able to be treated by penicillin, by methicillin, by vancomycin, and now those same staph are resistant to these diseases, and they've been called MRSA, methicillin resistant, or multiple resistant Staphylococcus aureus. Travel, because we've increased travel, diseases that are common in one country are becoming more common in other countries as well. Um, I'm going to stop here on this lecture, and then we'll go into the last section in the next lecture.